Dear students, today I am going to explain you what is the Curie law. Okay, I am having this rod, let it is made up of iron, and this is a solenoid or a coil. Some current is passing through the coil, some current is made to pass through the coil. As a current is passing, and number of turns per unit length of this solenoid is N. What is Ni? Ni is the magnetizing force or magnetizing intensity, H. This Ni or H, which is a magnetizing force or magnetizing intensity, magnetizes to iron. Iron acquire magnetization, and that is called intensity of magnetization. When it acquires magnetization, mean that is measured by this parameter I, intensity of magnetization. And intensity of magnetization, it will be more magnetized if there is a more current passing. Okay, or there is a more H. If the value of H is large, I will be large. So I is directly proportional to H. H is small, I will be small. H is large, I will be large. H is greater, I will be greater. Okay. Now, secondly, the role of temperature, it is inverse. Inverse effect of temperature on I. Temperature, temperature does not favors to I. Because if I am talking like it is iron, this iron rod, which is there are many domains. In each domains there are many atoms, and every atom having magnetic moment along the same direction. So when I am applying some external magnetic field, so there is a alignment of the domain along the direction of the field. But if the temperature is high, then there will not be proper alignment of the domain along the direction of the field. The temperature behaves like a opposing role to developing the intensity of magnetization. So that's why I is inversely proportional to temperature. That means I proportional to H upon T. Or you can say I upon H proportional to 1 over T. And what is I upon H? This is a magnetizing force or magnetizing intensity. It develops I. So replacing this sign by a constant, and I over H is called susceptibility. Susceptibility is proportional to 1 over T. Replacing proportional sign by a constant, so it becomes C over T. C is constant. So this is called, this C is called Curie constant. So for paramagnetic and ferromagnetic, the susceptibility is not only a function of susceptibility is not only depend upon the material, it is also a function of the temperature. So if I plot a graph, if I take H upon T along this side, H upon T mean if I am increasing T, this factor decreases. Mean going along this side mean this factor decreasing, and this factor decreasing mean the value of t is increasing. And if t decreases mean h over t increases, then we go along this side. So we go on along this side by decreasing t or increasing h. You increase h, then you again go along this side. And if you are increasing t, then or decreasing h, then you go along this side. So remember this thing. Second, here I am having I. So okay, if you are going along this side means increasing h or decreasing t. Then what happens? The intensity of magnetization first of all increases, then after that it becomes constant. Now what is the reason that it becomes constant? Because like the same example domains, and you are applying the field. When you are increasing the field H, more and more domains they get aligned, and when more domains alignment of the more domains means increasing the value of I. But there is a limit. When all the domains they get aligned, then after that there is no possibility of further alignment. So if you increase H further, it will not be helpful for more alignment, because alignment will not be possible after a certain stage. So that's why intensity of magnetization then becomes almost constant. Mean it is saturated. I saturated now. Okay. So this is all about the Curie law. What is hysteresis? The dictionary meaning of the hysteresis is coming late. What's the meaning of coming late here in physics, especially in magnetisms? Okay. Same example. I'm having some iron piece, and there is a coil. Some current is made to flow, right? And then Ni, mean current is flowing, number of turns per unit length. So it is H. If you increase I, the H will increase. Then we will measure what is I, intensity of magnetization, or B, magnetic induction. One and the same thing. Whether you measure P or you measure H with increasing H. So first of all, I just show you the graph. With increasing I, mean increasing H, I will measure the value of I or the B. Then I plot a graph. So the graph will be like this. First of all, it increases, then becomes constant. Why it becomes constant? You know well. Because again, this is a ferromagnet. There are domains in which magnetic moments they are aligned, but domains are random. Okay, they are randomly oriented in space. But when you apply the magnetic field, what happens? The alignment starts. So alignment starts means the intensity of magnetization is increasing. Mean I is increasing. There is more and more domains. They are aligning. Alignments of the more and more domains. Intensity of magnetization increasing with H. How I am increasing H? By increasing magnetizing field. How I'm increasing magnetizing field? I'm increasing this current. So current increasing H, more alignments, and that means intensity of magnetization increases. But a stage reach when magnetization becomes constant, because uh, the domains, they can be aligned. It happened. There is no further alignment is possible. So that's why no further alignment possible. So that's why it is a saturation. So this is graph from O to E. Now next, what I am doing. Now next. Now I am going to decrease I. When I am going to decrease I, H will decrease. H will decrease, I will decrease. And we are thinking we should retrace now the graph back, but it should come along this side. When you are decreasing H, I will decrease, so it should follow this path, because you was traced from O to A like this. Or when you are decreasing H, the retracing should be A to O back along this curve, but it not happened. With decreasing H, no doubt I decreases, but in a slightly different way, like this. It decreases, but like this. Mean the graph takes a different path. Of course, the path shows I decreasing with H, but not in a same way, but in a slowly. It is coming slowly. There is a slow decrease in I with respect to H. So that's the meaning of the hysteresis. Hysteresis means coming late. So it is not coming fast like it was going. It is coming slow. So that is the meaning of the hysteresis. And look, when I was decreasing, the graph retraces its path like this. Now here, H is totally 0. You made H 0 because you made current 0. No current is flowing. No current is flowing, even then the material having some intensity of magnetization. Means suppose this iron becomes north and this end becomes south with the presence of the H. But when H is made 0 or I is made 0, even then there is some pole strength. There is some pole strength. Some pole strength means there is some value of I which left. And the value of I which left when H is 0. So magnetization which is left, the value of I which is left when H is 0, this is called retentivity, very important phenomena, retentivity. Or it is residual magnetization left, even the current is 0. Okay, residual magnetization of the material. Now, what next? Now we are going to pass the current not along this direction, but we are changing the direction of the current. Okay, let the current is made to pass along this side. Okay, current is flowing along this direction now. So if you are making current to pass along opposite end direction, what happens? This residual strength of this residual magnetization, it starts decreasing. So it starts decreasing mean side. Going along this side mean you are increasing H again, but in negative direction. H is having negative value. Negative value mean you made the current in opposite direction. You allow to current you are made to current to flow in opposite direction now. In opposite direction mean now this H is negative and I is decreasing, residual magnetization decreasing. Ultimately, at some value of negative H, the I becomes 0. This is again very important. So, this is magnetizing force OC. With the magnetizing force OC, negative magnetizing force OC, it makes the OC is the negative value of the magnetizing force. It forces the retentivity to drop to 0 value. Retentivity, it drops. So OC is the reverse magnetizing force and it drops the retentivity. What was the retentivity? O to B. This was the retentivity. This negative value of H, it drops the retentivity to 0. This phenomena, this value OC is called coercivity of the material. Coercivity of the material is that negative magnetizing force to make the retentivity to 0. Okay. Now we still further go on increasing H. Now what happened? Instead of this N, now there is no N, there is no S because retentivity is 0 now. You are going along this side, mean you are increasing the value of H and I will start increasing. I now negative I. Now negative intensity of magnetization means this phase now becomes north pole. And again a stage reach when it is maximum magnetized, not possible further. Then there is a saturation. Now then you go on decreasing I, the value of this I, negative I decreases, means this negative I decreases. Ultimately, at some value of H, negative H, where this, so we go on decreasing I, then what happened? This intensity of magnetization, which was negative, it decreases. Ultimately, we made the current 0, but even then, there left some intensity of magnetization. We left some pole strength N and pole strength S, mean again retentivity. This again retentivity. Now what you do? Again reverse the current. Now current is made to flow again along this direction, and you make it to increase. The residual magnetization decreases. Ultimately, at some value of this I, okay, mean positive H, the this negative I reduces to 0. Now there is again no pole strength. So we are reached here. There is no pole strength, no I. Here becomes the north pole now, and here becomes the south pole. So that's why again intensity of magnetization increases and again becomes maximum. So this process repeats itself. So we got a loop, and this loop is called hysteresis loop. And two events are very important: this retentivity and coercivity. This, retentivity, this is the retentivity, this is the coercivity, and this is a loop. I think it is clear to you. This loop is, why this loop is important, why hysteresis loop is important. Please write me some words in the description box. Okay, thank you.